Let's see this problem, word ladder. What is its statement? A transformation sequence from word begin word to word end word using a dictionary word list is a sequence of word begin word S1 to S2 to Sk such that every adjacent pair of word differ by a single letter. Okay, that means each pair of word has only one word, one character different. Every SI for 1 to K is in word list. Note that begin word does not need to be in word list. Okay, begin word can be outside of this word list. Sk equal to end word. Given two words, begin word and end word, and a dictionary word list, return the number of words in the sorted transformation sequence from begin word to end word or 0 if no such sequence exists. Okay, from begin word to end word we have to go and we have to find out how many number of words has come. That means how many words transformations are there. Just see this example. There begin word hit, end word cog, and word list is hot, dot, dog, lot, log, and cog. So its transformation is like this: hit to hot to dot to log, dog to cogs. So see there is only one character change: hit to I to O, hot to dot, so H to D, dot to dog, D to G, dog to cog, D to C. Okay. So finally cog has come. So there are 5 words long. So which is 5 words long. So that means total 5 times it has been changed. From initially this was hit 1, so total 4 times it changed. So total are there 5 words long. And second example, from hit and cog. So see cog is not inside this word list, so it will return 0. Okay, just let's see its explanation. What I have done, I have taken this begin word hit and end word cog. Okay, and here word list hot, dot, dog, log, and cog has been given. So what I have done, I have taken pattern for each word inside word list. For hot, its pattern can be, there are 3 characters, so it's there are total 3 patterns will be hot, h hat, t, hot, h. Like in the same way for dot, hot, dhot, doh. For dog also hog, dhog, doh. For log also hog, lhg, loh. For cog also hog, chg, coh. Now what I have done, whatever are similar, take a list for those pattern. So see hot and hot both are similar here. Okay, sorry, hot both are similar. So for these two patterns there will be a list of hot and dot. See first list for hot, there is one pattern. For this pattern there are 2 words hot and dot. In the same way hog, hog, there are 3 words. So for hog there are 3 words: dog, log, and cog. This is second pattern. For h, ht, there is only one word, so only one word inside this list. For dht, only one word, dot. For dht, g, one word only, dog. One word pattern is only there. Log, chg also same way. HOH, there is only one word, hot. For DOH it is coming 2 times. So there are 2 words for DOH, dot and dog. For LOH only one word, log. For COH there is only one word, cog. Okay. Actually these words I have taken so that if I start from a starting begin word and if I change any its position, then I will check if there is any pattern inside this dictionary. Actually this is a dictionary. Okay, and for this dictionary for each key there is a list value for that key. So now see I have taken hit is the begin word. See hit is the begin word, so I will change each position of this character, this word, each character of this word I will change. So hit, nowhere is there this pattern hit, so no need to consider. hht, there is one pattern hht. See for this word is hot. Okay, for this there is one word hot, so there are 2 words changing hit to hot, so there are two numbers. So we will take one visited set, we will put whatever words we are visiting inside this set, so that there is no repetition. That means we have already checked now hot, so we will not check again this hot word. And inside this queue, whatever words are coming, we will put, so that we have to check this word again na? So we will pop this from this queue. So now total number of steps or total number of words changing 2, so hot and 2. Now I will check for hot. So for hot I will change each character. So hot, there are hot and dot, so new word has come, so I will push inside this set. I will add inside this set visited set, so hot and dot. I will check for another character change also, h t. For this hot was there, and hoh there was only hot, so no need to take hot because already it's inside this visited set. Now inside of this queue we have already popped this one ho hot. We will push this dot now inside this queue, so total number of character change word changes are here, hit to hot to dot, so 3. So 3 steps already done. Now I will check for dot. So for dot there are 3 character changes, hot, then you can see here I will match inside this nuddy, hot, hot and dot are there, so hot and dot already inside this queue, no need to take. Then dht dot is only there, no need to take. doh if we change third character. Then dot and dot already there, dog new word has come, so this will go inside of this queue, visited queue. So hot, dot and dog, 3 words are there. Now we have popped this dot, and again we will push this new word inside of this queue, so dog 4. Now see, this new word is there now inside of queue, we will pop this one. So we have popped dog, so for dog we will change each character position. So if we change first character position, then it comes hog. So for hog you can see hog there are how many, 3 words, dog, log and cog. So dog, log and cog, dog is already there inside visited list, so no need to put. And log and cog, these are not there, so log and cog we have added inside this visited queue, visited set. If we change second character, dht, dog comes, dog already there, no need to put. doh last word if we change dot and dog, already there no, dot and dog, no need to put. So now these 2 words has come again, so we will push both words inside of this queue, log 5 and cog 5, because this is fifth state. Okay, this is fifth word now. From heat to hot, see, first heat, then hot, then dot, then dog, and then here it has come log and cog. So we will what, pop and each word and we'll check from this queue. So log if we pop, of course it is not end word, but this is end word, so end word is find out, and here total number of steps are 5, so 5 will be our answer. So see, 5 times 1 2 3 4 5, so fifth word change is there, cog, so our answer will be 5. Okay, let's see the code of this word ladder problem. As I have already have discussed its explanation, so just here. So here beginning word, end word and word list has been given. So at first I will check if this end word is inside end word, not in word list. If end word not in word list, then I will return 0. Okay, if end word is not available in word list, then no need to check now. Next what I will do, as I already discussed, I will take one dictionary of list, tins collections dot default dict list. This is dictionary dt collections dot default dict list. Okay, so what I will store inside this dictionary, all the patterns of each word inside word list. Okay, so for word in word list, I will check for each word. So for I in range len word, for each word I have to check one pattern. So just take copy cp. This copy will be word I plus I will take hatch one pattern, okay, plus word I plus 1 to last, okay. And see, cp is the pattern, but I have to push all this inside this dictionary. I will append all the pattern inside dictionary for each word. So for each pattern I will append the word inside dictionary. So dt dot append, sorry, dt here for cp, for this cp dt, actually dt is the dictionary. So for this cp pattern we will append the word, okay. So there might be the case for the same pattern there are two words, so all those two words will be appended inside a list for this key value. In dictionary there are key and value pair, so here inside value there will be a list of words, okay. And this cp is the key, so pattern, this pattern cp is the key, and this word list is its value. So okay, in this dictionary those pattern and its corresponding words will be stored, okay. Now I will take one set already discussed, visited equal to set, and I will take one queue also, q equal to, this will be dq, and here I will start from begin word, and there are only one word here, so I will initialize it with 1, okay. Now I will go inside this queue, while queue I will pop, so bird and steps will be q dot pop left, okay. I will check now if this bird is equal to end word. If word equal to end word, then return steps. If this word is equal to end word. Now for each word I have to check its pattern now, okay. So I just copy this one for I in range len word. I have taken this pattern, but for each pattern there can be the case there may be multiple words, so I will check for each word inside this dictionary, because I will take the value key of this cp. So for ch in dt cp, see dt cp is what, value of the dictionary, and value is here list, so I will check each value inside the list, okay. And these value are word, original word which are inside word list, which we have stored inside this dictionary. So I will check if ch not in visited set, then I will add inside this set visited dot add this ch, and I will append inside q also, q dot append this ch and steps plus 1, because it will be next step, okay. So this is our final code. Now after coming outside of this while loop I will return 0. If no condition satisfied, then it will return 0. Just see again if it is correct, okay. Here if end word If end word not in word list, then return 0. Fine. I have taken one dictionary dt collections dot defaulted, and that will be list. Its value will be list inside this dictionary. So for each word inside word list, I have taken one pattern cp, and for each pattern I have appended those words for which pattern will be available there, as already discussed. And I have taken one visited set for comparing if we have already checked for that word or not, and this is dq. Inside this queue, what we will do, for each new word and each step, we will push inside this one, inside this queue. In this queue there can be multiple value also, so I have taken inside this list. So while queue I have popped words and steps. Fine. So if word equal to 21, we return steps, and again for inside of this word I have gone and I have taken its pattern, and I'm just comparing if this pattern is inside this, if this pattern will be inside this list, inside this dictionary, but this dictionary value is a list, so I will check for each word if it is inside this visited set. If not in visited set, then we will add. Okay, fine, in visited, and then we'll again push inside this queue, and this process will repeat. Just run this program. Okay, if ch in object is not callable, set object is not callable for ch in which, okay, fine. Oh, actually it should not be, no, only set name should be there. Okay, accepted. Let's submit. Okay, accepted. Thank you.